right, guys. Lesson 14, we're talking about combinations and composition of functions. So it is possible to tell the domain of equation upon first glance through implied domain. The domain is whatever doesn't make the denominator 0 or give a negative under an even root. All right, if x is even, and then that parentheses just explains what an even root is. All right, so if it's an even root, you have to consider both positive and negative, therefore a negative can't be underneath. All right, but if it's a cube root or a fifth root or whatever, then you can deal with the negative underneath. All right, so for this first one, if I have a fraction, all I'm going to do is I'm going to set the bottom equal to 0 and solve. And as we talked about in a previous lesson, I can factor this or I can do the square root property. So if I do x squared equals 4, I can take square root of both sides, I get x squared, or x equals plus or minus 2, which means those two are going to make the bottom 0. So if I take those out of my equation, or out of my domain, then I don't have a problem. So my domain in this situation would be x does not equal plus or minus 2. So I set them equal to 0, find out what makes it 0, and then throw it out. Now, for a radical, I'm going to set the contents of the radical greater than or equal to 0 and solve. Now, if you end up with a radical in the bottom of a fraction, it's just greater than 0 because I can't have it equaling 0 in the bottom of the fraction. Okay, so x is greater than or equal to 0. All right, so there is no throwing it out or anything like that. It's just greater than 0. So that's my domain in a situation like this. All right, so let's find the domain of the function. All right, first of all, if I have a list of ordered pairs, we kind of talked about this earlier on, but if I have a list of ordered pairs like this, my domains is the x's. So I got -3, -1, 0, 2, and 4. All right. For number 2, same thing, list of x's. So I got -2, -1, 0, 1, and 2. Okay, for number 3, I'm going to set the bottom equal to 0 and solve. So x plus 5 equals 0, x equals -5, but I don't want it to equal 5, so my domain is x does not equal 5. Okay, on 4, 3 minus x equals 0, 3 equals x, and I don't want it to equal, so domain is x does not equal 3. Okay. For number 5, this one's tricky. This is a volume formula. So there is no fraction, there is no radical, but volume is a unit of measurement, and they can't be negative. Radius, or units of measurements, cannot be less than or equal to 0. So for 6, same thing. R is going to be greater than 0. Okay. For number 7, now we have a radical. So I take the inside, 4 minus 3x, and set it greater than or equal to 0, and then I just solve. I don't throw anything out, I just solve. All right, so I got -3x greater than or equal to -4. I'm dividing by -3. When you multiply or divide by negative, you flip your inequality. So I got x is greater than or equal to positive 4/3. And that is my domain. On 8, I got x minus 16 is greater than or equal to 0. X is greater than or equal to positive 16. That's it. Again, when you're dealing with radicals, you're not throwing anything out. All right. Combinations of functions. Just as two real numbers can be combined by adding, subtracting, multiplying, dividing, the same is true for functions to create new functions. And here's a list of what it looks like. You're just adding, subtracting, multiplying, dividing. All right, so for number 9, it says f plus g of 3. So this is the same thing saying, as you can see, f of g of x is the same thing as f of x plus g of x. So when I'm given a number like this, the easiest thing to do is plug it into both and find out your answer. So 2 times 3 plus 1, that's going to be 7. G of 3 is going to be 3 squared plus 2 times 3 minus 1. All right, 9 plus 6 is 15 minus, this would be 14. All right, 7 plus 14. Okay, well, I'm adding these functions together, so 7 plus 14 is 21. All right, so that's my answer. Same thing on 10, I just plug it in. So I got f of 2 is 2 squared, which is 4. G of 2 is going to give me 1 minus 2, which is negative 1. 4 plus negative 1 is 3. So that's my answer. All right. On number 11, I'm subtracting. So f of 2 equals 2 times 2 plus 1, which is 5. G of 2 is 2 squared plus 2 times 2 minus 1. All right, so you got 4 plus 4 is 8, minus 1 is 7. All right, so it's f minus g. So I got 5 minus 7 equals negative 2. All right, so it's not big minus small or anything like that. It's the order they give you. They said f minus g, so that's what I did. All right, 12. I got f of 3 equals 3 squared. G of 3. I got 1 minus 3. 3 squared is 9. 1 minus 3 is negative 2. I'm subtracting, so I got f minus g, so that's going to be 9 minus negative 2, which is positive 11. Okay. 13, I'm multiplying this time. So I got f of 4 is 4 squared, which is 16. G of 4 is 4 minus 3, which is 1. 16 times 1 is 16. All right. 14. F of 3. That's going to be 2 times 3 plus 1. That's going to be 7. G of 3. It's going to be 3 squared plus 2 times 3 minus 1. 3 squared is 9. 2 times 3 is 6. 9 plus 6 is 15. Minus 1 is 14. All right, so I'm multiplying. 7 times 14 is going to give you 98. All right, so there you go. Number 15. All right, so when you're dividing, there's not a whole lot you can do except find the domain. So I just put 1 over the other, so I got square root of x over square root of 4 minus x squared. And I want to know what the domain is. All right, there's not much I can do there. I have a domain at the top, which is going to be x is greater than or equal to 0. But on the bottom, I got 4 minus x squared is greater than 0. It can't equal 0 because it's in the bottom. So I got let's see, I got negative x squared greater than negative 4. X squared is less than positive 4. Take square root of both sides, you get x squared is less than plus or minus 2. Okay. So what that means is I can say negative 2 less than x less than 2. All right, so the best thing to do here is I need an overall domain. So I'm going to draw a number line and plot both of them. So my domain on top, I got negative 2, 0, and 2. My domain on top is greater than or equal to 0. All right, so it's like so. My domain on the bottom is parentheses on negative 2 and 2, shade in between. So my domain for this entire thing is where does it overlap? Okay, so I have this and this. The overlap is my answer. Okay, so that means I got greater than or equal to 0, or 0 with a bracket, and then 2 with parentheses. And so that is my domain for this problem. And that's basically what you do. You set it up. Your function is the square root of x over the square root of 4 minus x squared, but your domain is the biggest part of this problem. And you find the domain at the top and bottom, you graph them, and then you find the overlap. All right, so this is the same set of functions, but now it's in the other direction. So I got 4 minus x squared on top over the square root of x. This time, I got x's less than or equal to plus or minus 2. And this is x is greater than 0. Okay, so that means I have domain -2, 0, 2 on top. I have brackets this time. And then on the bottom, I have greater than 0. So it gets parentheses. And again, my answer is in the overlap. So it's very similar to the one we did before, but this time 0 gets the parentheses and 2 gets the bracket. So where it falls in the fraction absolutely matters. Okay, so composition of functions. A lot of times you'll see it written with the f of g of x like this. I don't like it that way. I like it this way because this is more clear of what you're doing. You're taking one function and plugging it into another. Okay, so here's what we got on number 17. So this is f of g of x. So I'm going to take g and plug it into x for f of x. So this is going to be 4 minus x squared plus 2. And then I'll clean it up, and that's going to be negative x squared plus 6. And that's your answer. For 18, this is g of f of x. So I'm taking f and plugging it into g. So that's going to be 4 minus parentheses x plus 2 all squared. All right, so I'm going to have to expand that out. 4 minus x squared plus 4x plus 4. And I keep the parentheses for now because I got to distribute the negatives. So it's going to be 4 minus x squared minus 4x minus 4. And as you can see, the 4's fall out. And so I'm simply left with negative x squared minus 4x. Okay, you don't have to take a GCF or anything. You're just trying to simplify. 19, this time we have g of f of negative 2. So what this means is I need to find f of negative 2. What is that? That's going to be negative 2 plus 2, which is 0. All right, and because this is g of f of negative 2, the answer I get for f of negative 2, I plug into g. So I'm going to say g of 0. And when I get this answer, I'm done. So 4 minus 0 squared is 4. That's my answer, 4. Okay. 20. Let's see. F of g of x. Let's see. We got taking g, plugging it into x, or plugging it into f. So we got 2, 4, x squared plus 1, close parentheses, plus 5. Distribute the 2, clean it up. You got 8x squared plus 2 plus 5. So this is going to be 8x squared plus 7. Okay. 21. We have g of f of x. So I'm taking f and plug it into g. So let's see, we got 4 times 2x plus 5 all squared plus 1. 4 times, that's going to be 4x squared plus 20x plus 25 plus 1. Distribute the 4, you get 16x squared plus 80x plus 100 plus 1. So clean it up. X squared plus 80x plus 101. All right, that's your answer. All right, so this is f of g of 1/2. So this means I'm going to take g and find 1/2 when I plug it in. All right, so it's going to be 4 times 1/2 all squared plus 1. And when you square a fraction, you square the top and bottom. So this is going to be 4 times 1/4 plus 1. 1/4 of 4 is 1, so 1 plus 1 is 2. I'm going to take 2, plug it into f. F of 2 is 2 times 2 plus 5. So that's going to be 9. All right. All right. so sometimes you'll get these with a graph. And so what does this mean? All right, well, you need to find out when x is -2, what is g? So x is -2 right here, and I go up to g is in red. When x is -2, g is 0. So g of -2 is 0. So I'm going to find out what f of 0 is. And so I have x is 0. I go up to the graph, and that means when x is 0, f is 4. So 4 is my answer. All right. Find the domain of composite functions. Okay. So on 24, g is my interior function. So I got f of g of x, which means to find the domain of the interior function, I need to find the domain of g. All right, so the domain of g is going to be x does not equal 0. All right, so now I find out, I plug them into one another. So this is going to be, taking g, plug it in, so this is going to be 2. So I got 2 over g of x minus 1. So if I work this out to find the domain here, I got g of x minus 1 is 0. All right, I solve for g of x. But g of x is 3 over x. And so I multiply both sides by x. And so I get x equals 3, which means my domain for this thing is x cannot equal 3. Okay, so what does all this mean? Well, if I were to graph this, it can't be 0 and it can't be 3. But it can be everything else. So you write that like so, negative infinity to 0, 0 to 3, union 3 to infinity. All right, so you found the domain of the inside function, and you found the domain of the final function, and then those together is your domain of the new function. All right, let's do this again on 25. This time, once again, you got f of g of x. So the inside function is g, so that's going to be the same thing as before. D cannot be, it's going to be x equals 0. So d, my domain is x does not equal 0. All right, and so when I plug this in, I got 4 over g of x plus 2. All right, so that means that g of x plus 2 equals 0. G of x equals -2. Well, g of x is 1 over x. I'm doing it this way, like I did on 24, simply to keep the fractions out of it. Students already don't like fractions, so if you put fractions inside of fractions, it gets really dicey. So, but if you do it like this, it's much simpler. Don't include that second fraction until you have to. So this 1 over x equals -2. Okay, so that's going to be 1 equals -2x, and then divide, and you get 1 -1/2 equals x. Therefore, my domain on this one is x does not equal -1/2. Okay, so I can't include 0, and I can't include -1/2. All right, -1/2 is to the left of 0, so I got negative infinity to -1/2, -1/2 to 0, and then 0, 0 to infinity. And there you go. All right, last thing we want to talk about in this lesson is decomposition of functions. And this one is easier than it sounds. So think about it like this. H of x is simply f of g of x. I want to know what the inside function is and what the outside function is, and can I get the same thing back? And this is really open to interpretation, but there's some tips and tricks to this that I want to point out to you. So f of x, g of x. All right, so you see that you have this big nasty thing inside the parentheses, raised to the 5th power. Well, if you let the inside of that parentheses be g, to get 3x squared plus or minus 4x plus 1, that means f of x has to be x to the 5th, and here's why. So if I'm doing f of g of x, that means I needed to have an x to plug g into, and if the entire function is raised to the 5th power and there's nothing else going on, that means the parentheses itself represents x. And so this is one example of how you could do this. Like I said, these are not cut and dry. There's typically more than one answer to do this, but this is just one option to do it. On 27, again, I'm going to take the inside of that. So I got f of x, I got g of x. I'm going to take the inside function and let it be the inside of that radical. So if g is the inside function, that means x squared plus 1 is going to be g of x, which means that I got the cube root of x for f. Okay? If any of this, if you still have questions about any of this, please reach out. But otherwise, I'll see you in the next lesson.